Hello everyone. Finally, I am back. Today I am going to start a new series that is verification with Kittu. In this series, you will see a multiple project where we take real RTL design and verify them step by step using System Verilog and UVM. And the best part, I will be sharing the complete code of this project with you. So what are you waiting for? Join me in this wonderful journey where first we will understand the intention of our project, then explore the RTL. So move on to the building test bench, and finally I will share some bonus insight to make your verification journey more stronger. And if you want me to cover any specific project, so just drop it in the comment. I will try to make a separate video on that soon. So let's not waste any more time. Let's start today's video. So today I am going to verify our header. So I have one RTL of header and we are going to verify it using UVM. So my name is Kittu Patel, and if you have any difficulty and if you face any difficulty, so feel free to reach out to me. Now this flow we are going to follow. So first of all we will understand the architecture, and then we will see the RTL design of header, and then we are going to implement our architecture, or you can say implement our test bench using UVM, and then finally we will conclude our video. So the first part is architecture. So you can see the architecture. कितना मस्त बनाया है ना यार. अब इसमें कुछ लिखने की भी इच्छा नहीं हो रही है. So see, first of all we have transaction. So in transaction we are going to declare some signal, either it's rand type or not rand type. Okay. Now after that we have sequence. So in sequence we are going to randomize some transaction. Okay. So here we are going to randomize. Now here we have sequencer. So the role of your sequencer is just it act like a mediator between your sequence and driver. So your sequence will generate some sequence, and the role of your sequencer is to pass that sequence into a driver. So in sequencer you have two FIFO, that is request FIFO and response FIFO. So whenever driver initiates some request, so it will just check the FIFO of that sequencer. If there is some transaction in that FIFO, then driver directly get it. But if there is not any transaction inside the FIFO, so driver have to wait until there is some transaction inside that FIFO. Okay. So that is the role of your sequencer. So it is just acting as a mediator between your sequence and driver. After that we have driver. So the role of your driver is to pass the signal which you are getting from the sequence to your interface. So see, you can consider like this. So this is your driver, and this is your interface, and this is your duty. Okay. So this is your driver and this is your interface. So you are passing your signal to the interface, or you can say you are passing your stimulus to your interface, and from interface you are passing to duty. Okay. So your stimulus is going to duty, and in duty we are performing certain operation. After that we are sampling it into monitor. Okay. So this is the flow. After that we are passing it to the monitor. So here in between this, consider one interface. So driver can pass it in the interface. So from interface duty is connected, so duty can perform certain operation, and then it will send the output to monitor. So monitor will sample that output, or you can say stimulus, and then it will pass to the scoreboard. So here the role of scoreboard is to verify whether your design is working properly or not, or you can say whether your design are meeting the expectation which you have created or not. Okay. After that scoreboard we have agent. So in agent we are going to build our driver, monitor and sequencer. In previous video I have told you that we have mainly three types of agent, that is active agent, passive agent and reactive agent. Right now we are considering only active agent. Okay. Now after that we have environment. In environment we are going to build our scoreboard and also agent. Okay. So this is the role of your environment. Now after that we have test. So in test we are going to run our sequence. We will see each them in detail. Okay. Now our second part is, let's see RTL. So let's see. चलो चलते हैं. एंड अगर वीडियो पसंद आ रही हो तो लाइक कर देना गाइस. या ओके. सो okay, so this is our RTL. So you can see here, let me just zoom it. Yeah, so let me just, yeah, so this is our RTL. So you can see here we have considered module header A, B and sum. A, B is your input and sum is your output. We are considering in continuous assignment, sum is equal to A plus B. 5 bit. So if there is any change in A and one B, extra so bit, the output will get reflected. Okay. Now after that we have considered one interface. Here there is no need of using clocking block and mod port, because here we are not using any clock since it's an combinational circuit. So you can just write inside all your signals. So here in logic, we have considered logic 3 down 0, and A and B are our input and sum is our output. So this is your RTL. Now let's move to the verification. Yeah, now it's our verification. So I have already written this code, so I am going to explain each line in detail. You can just put focus on this. Now see here, first of all we have tick include UVM macros. So first of all we have tick include UVM macros.sph. So it allows you to use all the macros which was there with UVM, like tick UVM object utils, tick UVM component utils and all. Okay, so it allows you to use all the macros which was there with UVM. Now import UVM package and that scope resolution operator. So it allows you to use that, it allows you to insert the package or import the package of the immediate base class. So see here we have used extend sequence item, and this is all the base class. So this allow us to use that base class. Okay, now after that you also have to follow the same approach which I have followed. See, like I have started with transaction class. So while making any project, so you also have to follow the same approach. Okay, so this is our transaction class. So here our transaction class extend from the UVM sequence item. So keep this in mind. And since it's an object, so here we are using only one argument. See, in UVM we had component and object. In component we have two argument while making a constructor, whereas in object we only have one. Since our object itself a parent, so it will not require to point any parent. So that's why we are using only string. Okay, so it only have one argument. After that, see, like we have two input and one output. Now I have written my input A and B as an rand because I want the randomized input. So our A and B should be randomized, but output we are not randomizing, because see, like we are going to get our output from the design. We are going to generate stimulus A and B and pass it to a design, and then the from design we are going to, or we are expecting our output. Okay, now after that I have used a field macro. So see, the intention of using field macros is simply, you can understand it like this. If I want to print something, so that's why I have used a field macros. So now if I want to print something, so I just have to take the handle of this sequence or transaction. So transaction, let's say I have handled trans, so trans dot print. So whenever I am using this handle or I am invoking the print method, so I will see this all the fields, okay, in display. So that's why I have used here field macro. So here your transaction class get finished. After that we have sequence class. Now let's see the sequence class. Okay, so here you can see your sequence class. Now in sequence class we have extended from UVM sequence, and like we have considered one handle of transaction class, that is tr. Now our UVM sequence is an object, so that's why we have used here tick UVM object utils. And see, like we are able to use this macro because we have used or include our tick UVM macros.svh, and otherwise if we are not using this, so we are not able to access this. Okay, so after that we have constructor. Here also we have passed only one argument, and I have explained that reason why we are passing one argument. After that, see, we have task body. So when it will invoke, so whenever in test you are going to use start method, so your start method will invoke this task body. Okay, so I will show you that start method after that. Okay, but for being now you can understand, whenever your sequence being started, so it will invoke your task body. Now after that I have used a repeat 10, so that means I want to repeat or I want to generate 10 transaction, and after that I am creating or my object of that transaction handle, and then start item. So start item, so it will be wait for the driver to initiate the transfer. So whenever driver will look for the data, it will start randomizing. So until and unless it will wait for the driver. Okay, so it is blocking method. After that we have randomize. So here we are randomizing our data, and I have written if the value are not randomized, so there is no meaning of going further. So that's why I am showing the fatal. Okay, and if it is randomizing, then we are invoking finish item. So finish item is also invoke blocking. So finish item is also blocking. It will wait for the item done, okay, which was sent by the driver. After that we have used tr.print. Now here you can see we have directly used tr.print because in above one, or you can say we in transaction we have used field macros. So that why we are able to use this tr.print. So it will print all the fields which was there in, you can say, field macros. Okay, now after that we have sequencer. So here I have explained the role of sequencer. So your simple role of sequencer is to just act as an immediator, or you can say it will pass the transaction from sequence to the driver. So here I haven't written anything like logical. I just consider one component utils macro, and here since it's an component, so we have to pass two argument while making a constructor. I have done only this, okay, for sequencer. Now after that we have driver. So here see, like, so after that we have driver. See, while making any of the project or while making any protocol, the main part is driver or monitor. How you are sampling the data and how you are driving the data. Your entire protocols are dependent on that. Okay, so you have to take care while writing your driver as well as your monitor. So here in driver, since our driver is also like a, you can say, component, so we have used take UVM component utils. After that we have used a constructor. So since it's an component, so we have used two argument. Okay, now here you can see we have taken an handle of interface, because here we have to pass the values which we are receiving from the sequence into the interface. Okay, so we have to pass that value inside interface. So that's why we have taken, or we have considered the handle of interface. I hope it is clear. हो रहा है ना क्लियर? नहीं हो रहा हो तो बता देना, बताओगे भी कैसे, कमेंट तो करते नहीं हो. ठीक है, चलो. After that we have void build phase. So here the role of build phase is not just to interface or just to configure our config db. Okay, so here in build phase we are getting the config db which we have set it in our tb top. So here we are getting this interface handle. Okay, after that we have run phase. So see, run phase are blocking method. Now here we have used forever begin. So here we have used forever begin. So the intention of using forever begin here is to just continuously like monitoring our transaction that we are getting from the sequence. Okay, so sequence item port, that is the inbuilt handle or inbuilt tlm which was there in your driver. After that we have get next item. So when you are using get next item, so that tells your sequencer that driver is looking for some transaction. So your sequencer will get to know about that, like your driver is looking for some transaction. Then sequencer will pass that message to a sequence, that sequence can generate some data because driver is looking for that data. After we have used send to DUT, that is task. So here you can see this task. So in send to DUT we are doing nothing but whatever data we have received from our transaction class, that we are connecting to our interface. Okay, so see here we have received a, so that a we are connecting it to our interface, and b, that b we are connecting it to our interface. Now see, since we are not generating any output, so that's why I am not connecting it to our interface. Now after that I have used 10 unit of delay, because see here we haven't considered any clockage or any delay. So if we are not adding delay, so all this value will be more driven at only at once, so all the value will get overridden. Okay, so that's why we have used a 10 unit of time delay. After that send to DUT, you can see here item done. So item done means we have received our data and we have transferred our data from our driver, or you can say we have drive our data from driver to interface. Okay, so item done is also used to send the response to our sequence or sequencer. Okay, Now after that we have monitor. So your role of monitor is to sample the value which was there inside the interface. So monitor is also a component, so that's why we have used here take UVM component utils and monitor. After that we have considered one UVM analysis port. So see, your analysis port is nothing but it is used to broadcast a message from one component to multiple component. So here role of monitor is to just sample the data and broadcast it. Now the other components who looks for the data will get from this analysis port. Okay. Now after that we have one constructor. Inside the constructor we have two argument. अब तक तो पता चल गया होगा आपको दो आर्ग्यूमेंट क्यों ले रहे हैं. अभी भी नहीं पता चला यार, तो फिर तो मेरे पढ़ाने में कोई कमी रही होगी. Now see, like the handle for our analysis port is send, so we have just constructed our handle, so we have just created our object, you can say. Okay. Now after that you can see we have taken one transaction handle and interface. Now since we have to collect the data from the interface, so that's why here also we are considering the handle of interface. Just keep this in mind, we are going to use or we are going to take the handle of interface only in two components, that is driver and monitor, because driver has to drive the data from transaction to interface and monitor has to sample the data from interface. So that's why in these two components we are going to write interface or we are going to take handle of interface. After that we are doing the same thing which we have done in the driver and then in run phase. So see, in driver we are adding 10 unit of time delay. So in monitor also we are adding 10 unit of time delay while sampling, because because we are going to get our value after 10 unit of time. So that's why we have added 10 unit of time, then get from duty. So here get from duty task has been called, and then we are collecting our data, or you can say collecting our all the signals and values from our interface and making one transaction. Okay, so we have like assigning it to a transaction. So here you can see A, B and sum. See, sum we have received from design, like we have passed some stimulus from our driver, then certain operation was there in with design, and you can say certain operation has been done by the design and they are giving the output sum. Okay, after that we are sending this by using analysis port. Okay, so we have used write method. Now I hope it is clear. Here see, send is nothing but the handle which we have taken for our analysis port. Okay. Now after that agent. So see, the role of agent is simple. Here the role of agent is to just build your driver, monitor and sequencer and then connect your driver and sequencer. So here you can see we have taken three handle, driver, monitor and sequencer, and we have built them. Okay, after that we have connected our driver and sequencer. Now since like we have used inbuilt port, that is sequence item port and sequence item export, so that's why we have used driver dot sequence item port. So in driver side we have sequence item port and at sequencer side we have sequence item export. Okay, so we have connected them. After that we have scoreboard. So see, here the role of your scoreboard is simple. Collect the value from monitor analysis port and then check it whether we are getting the expected output or not. Okay, so here you can see we have used UVM analysis implement. In monitor we have used port because from there we have to broadcast, and in scoreboard we are receiving the data, so that's why we have used implement. Okay, now here I have taken one handle, that is receive. You can take it any name, you can give it any name. Okay, now after that I have just create this handle. Now here you can see, now since I have to get the data, so I have used function void write transaction tr, that is the handle. Now if tr dot sum, see this, like this output which we are getting from the design, and this we are like return some expected code, because since we are adding this, so if tr dot sum equal to your addition of this two number, so your test will get passed, otherwise it will get failed. Okay, now after that we have environment. So the role of environment is to just build your scoreboard and agent and connect your monitor to scoreboard. Okay, because here we are receiving data from monitor to scoreboard. You have sample certain data inside monitor, and then you are sharing it with scoreboard or other components. Okay, so that's why we are connecting our monitor and scoreboard here and building our scoreboard and agent. So here you can see we have builded our scoreboard and agent, and also we have connected our agent and scoreboard. Okay, now after that we have test. So the now after that we have test. So in test we are going to start our sequence. So in order to start a sequence we have to take a handle of sequence, and also we have considered handle of our environment, then we have builded them. After that, see, we have used rest objection and drop objection because all your component except your sequence are in forever loop. Okay, so your role for your drop objection is to just finish after, like, once your drop objection will get encountered, so your simulation will get finished or terminated. Okay, so that's why we have used drop objection. Now rest objection means your counter value will increment by 1. After that we have started our sequence, so we have considered the handle of sequence, that is sequence dot start. Now we have to consider the sequencer on which we are going to start our sequence. So this is the path for your sequencer. After that 10 unit, because see, monitor are sampling after 10 units, so we have to add one 10 unit delay in order to sample the last data. So we have used a 10 unit of time delay. After that I am dropping my objection. Okay, now this is your TB top. So from TB top, like, you have connected your interface signal to your like from TB top you had taken the actual interface handle, and then we have connected our TB to our design. Now we have used run test to run our test. After that we have set our config db from here, and here the role of, and here the intention of using $dump file is to just see the waveform. Okay, I hope all things are clear to you. Now let's see with a waveform. Now let's see the waveform. So let me run this code. Yeah, the code has been run. Now let's see whether it is working as per our expectation or not. We already have done addition in junior or senior KG. Okay, so you have to verify. I'm not gonna to verify. Yeah, dump file is loading. Now here you can see 10 plus 7 17. Oh, 10 plus 7 I think 16 na. So our test is failing. Okay, 10 plus 7 17. Okay, now 11 plus 3 14, 10 plus 9 19. Yeah, so we are getting the expected output. Okay, so also we can see here our tests are passed. So you can see test passed. Now here also test pass. It feels better when we are seeing test pass na? We are going to implement all the major protocols like APB, AXI, AHB. So there you can see like how we are going to implement test pass. So this is how we can implement our overall architecture. Okay, now our next video is on some sequential circuit. Either we can consider JK flip-flop or D flip-flop. We can write entire test bench code. Okay, so I hope you have liked this. I hope you liked this video. If this video feel valuable, so just like this video and also subscribe to our channel so that you can never miss any update from us. Okay, thank you.